Okay, so we are going to look at the extension from lesson 4.1 on page 213, where we're talking about transformation. So as we know transformation from past years, it's when we take geometric figures and we can move them on a coordinate plane. In this situation, we're going to be looking at different quadrants on those coordinate planes and how, with the three types of transformations, we can move geometric shapes. So again, we like to always look at that notation. It's how it's written. And so here we have just that reminder that we write transformation notation using an arrow, and that we are looking at extreme structure in how those letters are presented. Meaning, as we go through here, and oops, I think that's supposed to be in X. Okay, so we have here triangle ABC is transformed to triangle XYZ. Now in this case, it's showing mapping, or it's showing like how points are being moved. And so we can see with triangle ABC being transformed to that triangle XYZ, it's very important to keep the relationship with how the letters are put in order. So A is mapped to X, B is mapped to Y, and C is mapped to Z. Again, you're probably remembering, oh, well, that makes sense, because remember, like a line segment AB would compare to a line segment XY. And so again, the structure of how we're naming these different points and their transformation through or on a coordinate grid has to show that relationship between points and how they're being moved. As we go through this, you're going to notice I do have some notes already put into place because there's a lot of writing here. So let's go ahead and take a look at the types of transformation. We know that there's reflection, translation, and rotation. Reflection is when we flip a geometric shape. We could also say that that would be like having that mirror image of a shape. Many times we see reflection over the X or Y axes. So in this case, here is a line, and we can see that, again, I have triangle ABC, and it was transformed into triangle FGH. And we can map those points. Point A was reflected on that line to point F. A is to F. B, I can map it across that line of reflection to G. B and G have that relationship. And then, of course, we've got the C can be related to the H. Now we have our translation, which is to slide. And we know that on a coordinate grid, we slide up or down, or to the right or to the left. And so we can see here is our example of that transformation, triangle JKL, and how it is transformed to triangle MPQ. Our third type of transformation is rotation. Now, we normally see turns along a center point, I should say about a center point, and a lot of times we're going to talk about turns being clockwise or counterclockwise, and a lot of times we're going to see a 90 degree, a 180 degree, or a 270 degree turn. Now, as we're looking at that coordinate grid, we can talk about that 90 degree turn because along that point of origin, we see our 4 90 degree angles made out of our axes. So we're thinking about that 90 degree, maybe we're looking at a 180 degree turn. Okay, so you guys get that idea, right? So we have a rotation. When we're taking a geometric shape and we are turning it about a center point or a fixed point. Here we can see 3 different types of transformation. Here we have our rotation, and the bolder objects are going to be the original, and we can see that it was rotated into quadrant 1. It would have been a clockwise rotation of 90 degrees. For our translation, we can see that we are sliding our initial shape and it is moving down and to the right. Now we also are going to think about how is that related to your X and your Y. So really, I should have said, let's go to the right and then down. Okay, so we're moving, we're sliding shapes. Our reflection, as in shown with example C, you can see that that mirror or that line of reflection is on that x-axis. And so you can look at that original one and see how it has been reflected down. And of course, you know that a reflection, if you were to fold that paper on the line of reflection and you bring those 2 objects on top of each other, they would be congruent. Okay, we have quite a few examples today, so let's get started. I believe there's 9 problems to do. Okay, number 1. In number 1, we're just looking at, well, actually 1 through 4, we're just looking at points and just kind of talking about X and Y and our understanding of how those points are found on a coordinate grid. So here it says my X coordinate is -2, my Y coordinate is 1. Okay, easy enough. Number 2, I am a point B. Okay, so this was here, real quick, point A. And here is my ordered pair. For number 2, I am point B. X plus Y equals -5. My Y coordinate is -2. What is my X coordinate? X plus -2 equals -5. My X coordinate is -3. Right, so we're just doing a nice simple equation there. For number 3, I am point C. Okay, point C. X equals 2y. My horizontal position is 4, telling me the X location. If X is 4, 2y, 2 is equal to y, or y is equal to 2. So C is 4, 2. Number 4, I am point D. Start with A, okay. Start with -2, 1, and use the rule +3. Okay, so I've got a new X value of 1, -5, 1 minus 5, -4. Where am I? I am 1, -4. Now, as a quick reminder, what quadrant do all of these points sit in? Right? What quadrant? So, what quadrant is this? Number 1 is -2, 1. I'd be sitting in quadrant 2. B, I am negative, so I'm sitting in quadrant 3. Point C, I am positive, I am in quadrant 1. Let's just do my nice Roman. And D, I am 1, -4, I'm sitting in quadrant 4. As that reminder, you have your coordinate grid, coordinate graph, you have your X and your Y axes. We have positive, negative, negative, and positive, negative. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay. Let's go ahead and move on to number 5. So use the transformation rule. XY transforms to 3x and 2y. Graph the original and the new shape. So I've already gone ahead and I've graphed here this kite. And I'm going to go ahead and look at that. Original was 1, 0. So I'm going to apply this transformation of 3 times x and 2 times y from that original xy location. So we're going to look at 3 times 1, 2 times 0, 3, 0, 3 times 3, 1 times 2, 9, 2, over 9 up 2, 3, 2, 3 times 3, 2 times 2, over 9, up 4, and then we have 2, 2, which is our 6 and 4, over 6, up 4, okay, so as we look at this one, not only do we notice we have done some shifting, right? We have a slide happening. We also have a stretch happening as well. Okay, let's look at number 6. Graph the original figure, complete the table, and graph for the transformation rule. XY transforms to X, negative Y. So we're looking at taking the value of the Y and finding the opposite. So we have negative 2, 3. So we're sitting here. And we're going to go to negative 2, negative 3. Negative 2 down to negative 3. 3, 0. We're going to keep that x value at 3, and the opposite of 0 is still 0. So we are still sitting at 3, 0. And then we have our 1, 4. Our new one is 1, still for x, and we have a negative 4. So over 1, but this time we're just going down 4. So now I can see my green is the original, and that transformation is in black. What kind of transformation are we seeing here? We are seeing reflection, and even more so, it is reflection along the x-axis. Okay, and what's interesting, hopefully, is you're looking at that y value, we're looking at the opposite of the y value, which makes sense because we are looking at how that reflection along the x-axis will create that same x value, and we're getting the opposite because it is reflecting over the x-axis. Let's move on to number 7. So something happened here as we were going through this. So we're going to use transformation rule. XY is going to be transformed to x minus 5 and y plus 2. So what I've done for my notes is I've already placed our ordered pairs into the original XY values. I also went ahead and I just created some letters for these points. And now we're going to look at taking the rule minus 5 and plus 2. So we have x minus 5, 1 minus 5, negative 4, 3 plus 2, 5, negative 4, and then we're going to go up 5. We have 2 4s, so here we are looking at 2 minus 5, negative 3, 4 plus 2, 6. Negative 3, up 6. 4, 2, 4 minus 5, negative 1. 2 plus 2, 4. Negative 1, up 4. 3 minus 5, negative 2. Negative 2 plus 2, 0. 1 minus 5, negative 4. 0 plus 2 is 2. Negative 4 up 2. We can see here the shape, the orientation of the shape remains the same. The shape looks the same. It truly has just been shifted with a rule onto the graph. And so when we shift and when we slide, we know that we are talking about translation. Now, let's think about how did this translation happen? It's simply looking at taking the x and y value and we're doing a set rule for all points. Number 8. 2 more to go, guys. We got this. Triangle ABC is moved 2 units left and 3 units up. Draw the new triangle. So I just rewrote that rule here. 2 units left. So 2 units left. Well, we're on a number line, so we're going back 2. And 3 units up, positive 3. We're moving left on that x-axis. We're going up on the y-axis. I'm just going to take that x and put it here. We're on the x minus 2. Okay, so now we're looking at 3, negative 1. So if I really were to take A and just follow the rules, I'm going to start here at 3. I'm going to choose a different color. And it's saying take A and go 2 left, 1, 2, go up 3, 1, 2, 3. And now we have A. But remember, this is the copy, so this is A prime. And A prime can be found at negative 1, 0. Okay, this color is very hard on the eyes, so let's go ahead and we'll do some red. A little Christmas in September. Okay, there's our A prime. And that's just telling me that's a copy of the original point. Now we're going to look at B. We're going back 2. We're going 1, 2, 3 up. And there is B prime sitting at 1, 3. B prime is sitting at 1, 3. C prime, left 2, up 1, 2, 3. C prime. As I'm looking at this new shape, again, it looks the same. If I were to cut these 2 triangles out and put them on top of each other, they would be congruent. And I just need to finish off my C with it is 2 up 1. So what translation rule for XY? Well, we just actually wrote it out here as we were looking at the true meaning of moving left and then going up. So we're just looking at that rule written out. X minus 2, comma, Y plus 3. Okay, the last one. We just have a simple point at 3, negative 5. And we're moving XY. The rule, the transformation is 2x minus y. So we're just going to take and plug in 3 for x. So 2 times 3 is 6. And negative 5, well, the opposite of negative 5 is 5. So overall, what we're looking at is that we can take an ordered pair. We can apply rules of transformation to the ordered pair in order to find a new point on a coordinate graph where that point's going to have a copy made. Again, we looked at transformation. We talked about the 3 types of transformation. And we now are done with this